Math work anytime of day. So. Just kidding. Reminder, the quiz is due by 5 o'clock today. So if you haven't done it yet, make sure you get on that. Otherwise, you'll get 0. And that's not a good way to start off the semester. So, let's see. Today we're going to start in on chapter 1.6. Yesterday we talked about exponential functions. Today we're going to talk a little bit about inverse functions and logarithms. Oh yeah, that's right. See, that's the kind of excitement we need in class every day. Come on, everyone. Woo, next time, please. Okay. So when we're talking about inverse functions, the word inverse, should sort of bring to mind this notion of undoing something. Okay? And that's how we want to think about inverse functions, is that they're functions that undo another function. As an example, suppose we have something like y equals 3x, y equals 6x minus 3. Okay, so we have y equals 6x minus 3, and we know that this function exists. We know that we have this function, and someone says, okay, you have this function, but tell me, what value of x do I need to plug in to get 15 out? Okay, so here's our function. We start with what x value produces a y value of 15. How would you find that? How would you go through and figure out this question? Okay, so one thing you do is you take this 15, you'd stick it in here for y, and you would have a simple algebra equation that you could then go through and solve. You do that, 18 equals 6x. We arrive at the answer x equals 3. Okay? Alright, that's pretty straightforward. Now suppose that you had a list of 500 y values, and I asked you to solve for the x for each of those 500 values. Okay? Well, we could go through this same process 500 times, or we could try something different. How else? Or what else might work to do this? Okay? Well, what we're really trying to do here is, if you're given all of these y values, you're told that you want to undo this function that produced all of these y values. You want to undo it. You want to figure out, where were the x values that gave me these y values? Where did they come from? Okay? So what you can do is, instead of having to plug a different y value into this each time and then go through and solve everything, wouldn't it be better if we could just plug a y value in, do a simple computation, and out comes the x value we're looking for? Wouldn't that be easier than trying to solve these equations each different time? Alright, so suppose y naught is the value we're given. Find the x. Let's do that. Okay. Here we have some unknown y value. It's just, call it y naught. Y naught? Well, that's y naught. So we have y naught equals 6x minus 3. Okay. Alright, well, I want to know what x value this came from. So do some simple maneuvering here. Let's see, that's y naught plus 3 equals 6x, or y naught plus 3 divided by 6 equals x. This formula here, this little equation that I have written down here, what this will do for me is that if I have any y value whatsoever and I stick it into the left-hand side, do a simple computation, the x value that y came from is spit out on the other side. Right? It's a whole lot easier for me to stick 500 values into this equation than it is to stick 500 values into this and have to solve for x each time. This gives me x right away just by plugging in the y value. This, I have to maneuver things around and solve for x in a different manner each time. I would much rather work with this 500 times than have to to solve that equation of that function. Okay? This function right here, this function undoes the 6x plus 3 function. In some sense, you can think this is the inverse of that function right there. Okay? So, let's go g of y equal to y plus 3 over 6 is the inverse of f of x equals 6x minus 3. Okay? They undo each other. All right. Well, let's. One more thing. Sorry. One thing you'll notice here is this is in fact a function, right? This is a function. Each y value I put in spits out exactly one x value. So this is in fact a function. That's important, as we'll see in this next example. Okay? Suppose we're given the function y equals x squared. Okay. I want to find a function that undoes this. Can I find a function that undoes this x squared thing? Well, let's think about what we're doing here. When I put a number into the y equals x squared function, we're squaring it, and that's our output. Okay? Let's try to find some answers here. So let's find x such that y equals 9. Find the x that goes along with this y equals 9. How would you do that? Do what we did last time. We take the y, we sub it in for the 9. So 9 equals x squared. Solving that, what do we get? Okay. When we do this, unfortunately what we find is that we get two different x values that could give us this possible 9. Okay. Well, all right, that's not so good, right? Because if we were to try to find a function that undoes this, it seems like the undoing function I'm going to put function in quotes here, would look something like x equals plus and minus square root of y, right? This appears to be the function that undoes the y equals x squared. All right? Well, is this thing a function? Why is it not a function? We take, for any single y value that we put in here, we get two outputs. Right? Y equals 9 gives us plus and minus 3. Okay? So this is not a function. It's not a function. Yes, it does undo this x squared function, but it's by itself here, this thing is not a function. Okay? And so, y equals x squared doesn't have an inverse function like this 6x minus 3 did. Okay? All right, well, let's see. Why is that? Why does one of them have an inverse function, but the other one doesn't? What property of these things do we have to look at in order to determine whether or not they have inverses?
Does it have to be linear?
Every linear function is going to have an inverse, but there are functions which are not linear which also have inverses. Y equals x cubed, for example. Y equals x cubed has an inverse. Okay? What would that inverse be? In this case, x equals the cube root of y is that inverse. All right. Well, let's take a look at this maybe in a little different way. Maybe we can see something when we do it this way. I'm going to graph these functions, the three of these that we've got so far, and we're going to see if there's something about them that we can identify that maybe tells us why they do or don't have an inverse. So the 6x minus 3, 6x minus 3 looks something like this. Think about it. It's all right. Don't worry. Think about it for a second. We'll see if we can find something. So there's our y equals 6x minus 3. Here's our y equals x squared, more or less. And then finally, our y equals x cubed. There are our three functions on the board here. Okay. Two of these have an inverse, one of them doesn't. Okay. The one in blue does not have an inverse. The red and the black one do. Now, what properties, when you look at these things, do you notice? That's a valid answer. Even functions do not have inverses. There's a reason. There's a more subtle reason than the fact that they're even that comes into play there, though.
Draw a line that goes through the function twice.
Draw a line. I can draw lots of lines. What kind of line?
Horizontal line.
Horizontal line?
Yeah.
All right. If I draw a horizontal line, notice that the horizontal line that I've drawn here passes through the blue function 2 times, but it only passes through the other 2 once. Okay? That is one of the properties that we can utilize to identify whether a function has an inverse or not. Okay? This is what is referred to as the horizontal line test. Now, the horizontal line test is nice, a nice way of looking at these things graphically. A function f of x has an inverse if and only if any horizontal line intersects the graph of y equals f of x at most one time. Okay. So this horizontal line test is one thing that we can use to identify whether or not a function has an inverse. Okay. This horizontal line test is a graphical interpretation of a different property, and it's what's called one-to-one functions. And a one-to-one function, like 2 of the 3 we have on the board here, a one-to-one function is a function in which each output value comes from exactly one input. There's one and only one input value that goes to any specific y value. Okay? So a function f of x is one-to-one if every output, by output I mean every range value, comes from a unique input. Okay. So this notion of one-to-one can be interpreted in terms of the graph as this horizontal line test. Okay. This horizontal line test is just translating this mathematical definition of what a one-to-one function is into sort of a picture that we can view. All right. So we saw that x squared is not a one-to-one function. Let's see. Let's take a look at some examples of some functions and identify whether or not they have inverses. And you can utilize any method you want of doing this, but I'm going to give you some examples of some functions and ask you if they have inverses.